group 3A and we will present you our science project. We use water basically every day and cannot survive without it. It is one of the most essential compounds of the world. Also, we've all been told that water is made up of hydrogen and oxygen, and each part of the water molecule has a charge. But how can we prove that water is made up of hydrogen and oxygen? Well, we can prove it using electrolysis, which is the process of using electrical current to separate water into hydrogen and oxygen gas. This electrical charge applied will break the chemical bond between its atomic compounds and produce charged particles called ions. So join us to find it out.
Materials: glass or plastic tube, 2 test tubes, 2 rubber bands, baking soda, graphite pencil lids, water, battery, waterproof tape, and 2 pairs of alligator clips.
Connect one end of each crocodile clip to a piece of graphite and the other the battery. Secure the graphite ends to the bottom of the tube with the graphite sticking up, and place an inverted test tube over each piece of graphite.
In the video, you can see the procedure of the experiment. One end of each crocodile clip was connected to a piece of graphite and the other to the battery. The graphite ends were secured to the bottom of the tube with the graphite facing up, and an inverted test tube was placed over each piece of graphite, held in place by the rubber bands. The baking soda is then dissolved in the water and the tube is filled. Finally, each test tube is removed, filled with water, and carefully replaced on the graphite. Any gas collected during electrolysis will replace the water in the tube, so make sure there are no air bubbles. It can be seen that gas bubbles begin to form rapidly at each electrode. More gas accumulates at the negative electrode, cathode, than at the positive electrode, anode. To check his gas, he carefully placed the lids on the test tubes while they were still underwater. To test hydrogen, the test tubes were used together with the gas collected in each. A flash was observed at the cathode, negative, and the gas at the anode gave off brave glow but did not make any pops.
The gas collected in the test tube corresponding to the anode was oxygen. This gas was colorless and odorless. The presence of oxygen in the test tube was checked by introducing a lead phosphor into the test tube, where the phosphor gave off a brief glow.
To check if hydrogen was also obtained from the experiment, the test tube that was next to the negative cathode was checked, and the amount of gas that it had, which when manipulated released a greater amount of gas than its counterpart.
Oxygen is the most abundant element on planet Earth, making up approximately 50% by mass of the Earth's crust and forming 21% by volume of the atmosphere. The presence of oxygen was tested with a lead phosphor. If there is enough oxygen, the phosphor ignites. The gas we collect at our node gave a brief glow that confirmed it was oxygen. During electrolysis, the molecules are reduced at the cathode to hydrogen gas and oxidized at the anode to hydrogen gas. If water is dissolved in sodium bicarbonate, it dissociates into positive oxygen ions and negative hydrogen ions. When a potential difference is applied to the electrodes, the oxygen ions move toward to negative electrode, are discharged, and are deposited on the electrode as oxygen atoms.
Gas bubbles beginning to form rapidly were observed in each case. More was accumulated at the negative electrode, which is in the cathode, that at the positive anode, where hydrogen will appear at the cathode, where electrons enter the water, and oxygen will appear that to the limit autoionization of the water. Pure water has an electrolytical conductivity of millions of that of seawater. Many electrolytical cells may also lack the necessary electrocatalysis. The efficiency of electrolysis is increased by the reduction of the electrolyte, such as salt, acid, or base, and the use of electrocatalysis.
What happens when you use salt as electrolyte? It seems that during the electrolysis of sodium chloride solution, sodium chloride breaks down at the positive electrode to form chlorine gas and sodium hydroxide solution. Chlorine dissolves easily in water, so won't collect as a gas until the solution is saturated and can't absorb no more chlorine. So if our positive electrode was busy attracting chlorine and hydroxide was collecting at the cathode, what happened to the oxygen? According to the studies, the sodium and oxygen combine to make sodium hydroxide solution.
Conclusion. The conclusion of this experiment is that water can be separated into its two components by means of electrolysis, and that hydrogen will always be in a higher proportion than oxygen, and with this it was found that water is a compound.